From the last video, we introduced what is our arc length. Now let's looking at two examples. So the first one I want to find is I have a function f of x, which is 4 over 3 x to the 3 over 2, 3 halves power. We're going to calculate the arc length over the interval 0 to 1. So this is our function. And according to the formula, the arc length, or L, is going to be the integral from a to b square root of 1 plus f prime square dx. So f prime is going to be 4 over 3 multiplied by 3 over 2 multiplied by 3 over 2 x to the 3 over 2 minus 1 using the power rule, which is 2 times x to the 1 half. Now our a and b is going to be the 0 and 1. So the arc length is going to be integral from 0 to 1 square root of 1 plus the first derivative to square root of x squared. So the 1 half power is the same as the square root dx. I want to rewrite as a square root because it's easier for me to square it. Now to simplify it, we got 1 plus 4x dx. So to solve this one, I want to use a u-sub. So I'm going to let u be the 1 plus 4x, du is equals to 4 dx, or dx is 1/4 du. When x equal to 0, u is going to be 1 plus 4 times 0, which is 1. When x equal to 1, u is equal to 1 plus 4 times 1, which is 5. So the problem now becomes to integral from 1 to 5. Let me change the color. 1 to 5 of square root of u times 1/4 du, which is 1/4 u to the 1 half power is going to be u to the 1 half power 2 over 3 times u to the 3 over 2, and evaluate it from 1 to 5, which is going to be 1 over 6 evaluated at 5 to the 3 halves minus 1 to the 3 halves, where 5 to the 3 halves is 5 cubed, so 5 square root of 5, and then 1 to the 3 halves, which is just 1, and that's pretty much our answer. If you want to change it to decimals, 1/6 times 5 multiplied by the square root of 5 minus 1, which is approximate 1.697. But this is the one is more easier to communicate. Now we have another example, but this time the curve is y equal to x squared minus 1/8 ln of x over the interval 1 to 3. So using the same thing, so the y equal to x squared minus 1/8 ln of x, so the derivative y prime is going to be 2x minus 1/8 times 1 over x, which is 1 over 8x. Now the arc length is going to be integral from 1 to 3 square root of 1 plus 2x minus 1 over 8x squared dx. To simplify it a little bit, using some algebra, we ended up with 1 plus 4x squared, 2x times 1 over 8x, 1 over 4 times 2, 1/2, plus 1 over 64x squared, which is going to be 1/2 plus 4x squared plus 1 over 64x squared. And this, if I rearrange this 4x squared plus 1/2, this is pretty similar to the perfect square we just multiplied it, which will end it up as 2x plus 1 over 8x squared dx. So we can take the square and square root out. Now this one we know how to find the antiderivative, which is going to be 2 times x squared over 2 plus 1/8 times ln of x. So we will simplify it. We got x squared plus 1/8 ln of x, evaluated from 1 to 3, which is going to be 9 plus 1/8 ln of 3 minus 1 minus 1/8 ln of 1, where ln of 1 is equal to 0. So we ended up with 8 plus 1/8 ln of 3. If you want to use this calculators in the decimal form, that's going to approximate it as 8.1373. But again, this is the more easier way to communicate.